Hello friends, welcome to my YouTube channel, and today we're going to start a new course, that is complex analysis, and these are the topics we're going to cover in this series. And our first topic is brief revision of complex number. Okay, so I think you are aware of complex numbers. Okay, so but before we go to the other topics, Euler's formula, De Moivre's theorem, roots of complex number, first we're going to discuss we're going to revise. Okay, a brief revision of complex number and graphical representation. This is going to be the topic of discussion in this video. Okay, so this is going to be the topic of discussion. So now let's start. What is complex number? So before we discuss about complex number, we must know what is imaginary number. Okay, so if you are asked to find square root of 4, you can say easily it is 2, right? It's very simple. So when you are asked to find square root of -4, then what gonna be the answer? Okay, so in order to overcome this, we imagine a number that minus 1, square root of -1 is equal to I, which is known as imaginary number. Right, this is called imaginary number, right? And here you see, in using this concept, we can find the square root of this. That's gonna be, I square, that's gonna be -1, right? So I square gonna be equal to -1. So here we can write this one as this, and the square root of this now 2i, right? Now you see, a number of this form, a plus ib, is called complex number. This is complex number. This is complex number. Okay, so here a and b belongs to real number, and here a is called real part, right? Though individually b is it is a real number, but here in this complex number we're gonna say this is imaginary part. Right, so as a whole it is a complex number. A is real part, and the number which is multiplied by I, that gonna be called imaginary part, right? So now you see, suppose we have a complex number, that is z is equal to a plus ib, then conjugate of this number, then conjugate of z, that means a plus ib, is given by z bar, that is conjugate of z, which is going to be equal to minus a minus ib. Okay, when there is plus, then it's conjugate. Here it's going to be minus. Okay, so hope you know these things. Now what going to be the geometrical representation of a complex number? Suppose this is x-axis and this is y-axis, and here it is y dash, this is x dash, and this is the origin O, right? And we have a complex number z is equal to a plus ib. In that case, the coordinate representing this complex number, okay, the point representing this complex number, point representing this complex number is a comma b. Here a is the x coordinate and b is the y coordinate, and suppose this point is here, this is your suppose a comma b. Okay, right? And if we draw a line from here, you see, just wait. So here you can see, so this is suppose this point a comma b, and this is the point representing, suppose representing the complex number, that is a plus ib. Okay, so in that case, the length of this line, okay, the length of this line connecting the origin and the point, or the point representing this complex number, is called modulus. Is called, this r is called modulus of this complex number. And what gonna be its magnitude? Let me show. If we draw a perpendicular from this point to the x-axis like this, the red one, you can say this is the perpendicular, then here you see this length is a, and this length is a, and this perpendicular length of this perpendicular is b, then the modulus of the complex number is given by r is equal to, if you use the Pythagoras theorem, a square plus b square. Okay, so this is the modulus of the complex number, and written as mod of z, right? So this is nothing but modulus of the complex number, modulus of the complex number z is equal to a plus ib, right? Ib. And here this x-axis is called real axis, as it represents the point, the number here you see, which is the real part. This represents the real part of the complex number, and as y-axis, along y-axis, it represents the imaginary part. So that's why this axis is called imaginary axis. Okay, this is imaginary axis. Sorry, imaginary axis, right? Okay, now let us discuss about argument of a complex number. So let me here you see, let me copy this graphical representation, and let me go to a new slide. Okay, just wait, let me copy this whole thing. Okay, just wait, let me go to a new slide. Okay, here you see, if suppose here you see this line joining the origin and the point representing the imaginary number, the point representing the imaginary number and the origin, if the line joining these 2 points, origin and the point representing the imaginary number, if this line makes angle theta with positive x-axis, okay, if the line representing, or OP, if OP makes angle theta with positive x-axis, remember it must be always positive x-axis, right? With positive x-axis, then argument of z, that is given by arg of z is equal to theta. Okay, remember that. Okay, now you see, let us have let me tell you a few more things related to this topic, argument. Okay, so now let me go to a new slide. Now you see, if the point representing the complex number is at this quadrant, suppose at this quadrant we have the point representing the complex number. Suppose the complex number is, suppose now z is equal to, suppose minus a plus ib of this point, then minus a comma b is this point, right? Then here you see, if you draw a perpendicular here, and let me take this angle is alpha, right? Let me take this angle as alpha, and this is B and this is A. So here you see, in this case tan theta is equal to I am talking about the previous case. In this case, when it was in the first quadrant, tan theta is equal to B by A. Now in this case you see B by A, mod of B by A. Okay, we're gonna ignore the negative sign here. So now if the complex number is of this form, minus A plus IB, that means it lies in the second quadrant. So in that case, here you see, this is, let me consider this is this is alpha, then you're gonna have tan alpha is equal to, right, mod of minus B by minus A, B by minus A, that means it's gonna be simply B by A, right? Simply B by A. You can write that way. Just wait. So now you see, in this case, what will be the theta? Then theta will be this one. This angle is theta, right? So argument is always angle made by this line with positive axis. That angle gonna be always when we say argument, always we're gonna take the angle made by the line joining the suppose this is the x-axis, this is the y-axis. Here is positive x-axis and this is the positive y-axis. If the point is here, this is the line joining the origin and the complex point representing the complex number. So if it makes here alpha, then here you see, we can obtain this angle if you know the point minus A comma B, right? We can obtain this angle from this equation, tan alpha is equal to this. And so in order to obtain the argument, how to obtain this angle? We must in order to obtain the argument, we must obtain the angle made by this line with the positive x-axis, so that's going to be pi minus alpha in this case. So that's going to be pi minus alpha. So here in this case argument will be, so let me clean this here, argument of z will be pi minus alpha if the complex number is in second quadrant, right? Then what if it is in the third quadrant? Suppose here is the complex number. Suppose here is the complex number. Let me draw here. Okay, this, just wait. Let me write the origin here, and this is the complex number here. Suppose this is the point representing the complex number. If z is equal to minus A minus IB, right? So here minus A comma minus B. So now, so this is the perpendicular, suppose. So this is B and this is again A, right? This is A and this angle is suppose alpha, right? Just wait. Now let me take this case. This is A and this is alpha. This angle is now alpha, suppose, right? So now you see, now this angle made by this line joining the origin and the point representing the complex number, this angle will be again given, right? This angle is pi, right? This is pi, and this part is alpha, and if you subtract it, then you're gonna get pi minus alpha. But when you go clockwise direction, in the clockwise direction, so this is the coordinate. When you go anti-clockwise, then we're gonna take positive, and when you go clockwise, then we're gonna take negative. So here we're gonna take a negative sign, and in that case the argument is gonna be equal to, so here again tan alpha gonna give you the B by A, right? And the argument gonna be argument of z, it's gonna be equal to minus pi here, within bracket minus within bracket pi minus alpha. That's gonna give you minus pi plus alpha. That's what we're gonna have, right? That is what we're gonna have. So hope this thing's clear. So when we're gonna have this kind of argument, when the number is in when the complex number is in third quadrant, when it is in third quadrant. Okay, when this z is in third quadrant, right? So let me write it properly. Just wait. Third quadrant, and here 10 alpha is again b by a, right? Now you see, let me clean these things. Okay, so what if it is in fourth quadrant, right? So in this case, let me clean this thing. So if it is in the fourth quadrant, here you see, this is the fourth quadrant. So this is the perpendicular. Suppose this is b and this is a, and this angle is, suppose now, theta, or you can say minus alpha. Let me take alpha. So this is, suppose this angle is, suppose now alpha. Just wait. This angle is now suppose alpha, right? This angle is alpha, made with the positive x-axis, but in the clockwise direction, right? So if z is equal to, so here the coordinate gonna be, positive a, negative b, right? So that means a minus ib, okay, in the fourth quadrant, and again 10 alpha gonna be mod of b by a, and here the argument of z gonna be given by theta, which is equal to minus alpha, because we are going now in clockwise direction. In clockwise direction, we used to take negative, right? And in anti-clockwise direction, we used to take positive. Okay, so hope you have understood these things, how to find modulus, how to find argument in different conditions of a complex number, right? So these are the basic things of about complex number. So I think you know these things. You have studied in your senior secondary level, and those students who are from Assam and they studied under Assam Higher Secondary Council, those who have studied study in state board schools under Seva board. They have got in class 10 if they have taken advanced mathematics, right? If they have taken advanced mathematics in Assam under Seva board, then they must have got these things in class 10 as well. Okay, these are very simple things. Now our next topic is polar form of a complex number. Let me go to the new slide. Here you see. So here is the x coordinate, here is the y coordinate. So let me clean these things, we don't need now, just wait. And here is the point representing the complex number, that is a comma b, and this represents the complex number z is equal to a plus ib, right? And this is the modulus of this complex number, and here is the suppose perpendicular, and this is a, this is b, and this angle is theta, which is the argument, right? So in this case, here you see z is equal to a plus ib, right? A plus ib. Here you see, we can write sine theta from this triangle, from this triangle. What we can write sine theta, b by r, perpendicular by hypotenuse, and cos theta. Cos theta can be equal to a by base by hypotenuse, that is a by r. And we know that r is equal to given by root over a square plus b square. So in that case, b by, this is root over a square plus b square, and it's gonna be a by root over a square plus b square, and from these two what we can write, we can write b is equal to root over a square plus b square sine theta, and here a is equal to root over a square plus b square cos theta. So in complex form we can write that complex form z is equal to a plus ib, and complex form of this form of z is equal to a plus ib, that's gonna be given by, if you replace the a by this value, then you're gonna get root over a square plus b square cos theta, then plus I, let us replace the b by this value, root over a square plus b square sine theta, and if you take this part common, then you're gonna have this root over a square plus b square cos theta plus I sine theta, right? So this is the complex form of z. This is the complex form of z, that means the complex number, polar form of z. This is the polar form. I have written here complex form, polar form of complex number, right? And you can write, instead of this, you can write r into cos theta plus I sine theta as well. So this is the polar form of a complex. These are the basic things we must know before we go to the depth of this course. Okay, so hope you like this lecture and you have understood. I hope you have understood what I have explained. Okay, and if you understood that, then please subscribe the channel if you are new to my channel. Also share with your friends and inspire me to create new contents for you. Okay, so I'm going to continue this journey, okay, creating new course for you. Okay, and see you in the next video. So we're gonna discuss another topic, okay, related to this complex analysis. Okay, so see you in the next video. Thank you for watching.